Hi everyone. So this playlist, it is a compensation of a few classes that we have missed along the way, including the last class that we missed, probably because of the lab exam that you had. We are again going to look at the problem of race condition, and this time we will figure out easy solutions. So as I told you through my message on the WhatsApp group, software solutions, they can grow really tricky, and I am sure that all of you had a tough time with the last week's lab, and some of you might still be struggling to complete those checkpoints. So what we are starting now to understand that you need not know the entire Monday's lab completely, although you should do that slowly with time, but to understand what's going on here, you should ensure that you have completed checkpoint 1 and 2. So if you have completed checkpoint 1 and 2, you are good to go to watch these videos. You'll be able to understand this, and we will try to resolve the problem of race condition in an easy way over here. So this code that you see on my screen over here, it is the first code from your lab document, right? The Google Drive link for which was given to you, the base code that we started with probably the only change being in the number of iterations over here. So you can always change this number of iterations according to you. So I again wanted to highlight the concept of race condition here with a different analogy, and which is rather a joke, and it might be a poor joke again a disclaimer, right, but it goes well in the context of what we are speaking now. So there was this Pinky joke that I once heard, that this little girl Pinky who goes to her mother and complains that, "Mom, you see, Bhaiya has, my brother, he has broken my doll." And then the mom goes and scolds the brother, and then she asks Pinky, "How did he break your doll?" And then she says, "I actually attacked him with the doll on his head, and in the process it broke." So the moral of the story, when we are complaining to someone, to a third party, right, it could be siblings, it could be husband, wives, or anyone, the point is, whenever we are complaining, we only tell the mistakes of the other side and really hiding our own. So in that same context, let us stitch an analogy here. Let's say you are working with your friend on a project, and then something doesn't go really well among both of you, and now both of you want to talk to the professor, and let's say professor is in his cabin, and both of you are standing outside the professor's cabin, and both of you want to, you see, complain about each other. So would you really go inside at the same time? Probably not. So that's the same problem that we are dealing with here. If you look at the producer and the consumer, race condition happens when both of them are trying to access the value of count at the same time. So what we want to preserve here is only one of them should be incrementing or decrementing count at the same time. That is our objective. So again, similar to, let's say, if not you or your friend, they are Ram and Shyam, who are waiting outside a professor's cabin, but then the point is both of them don't really want to go at the same time, so that they can complain with their heart out, right? So they don't want the other person to be there. Now there are two ways of looking at this problem. So one way of looking at it is what happens exactly as in the real world. So both of them go to the professor's cabin, and it is like a parallel execution over here. And let us say the door is open, there is no lock, the professor is inside, then both of them shouldn't go at the same time, right? Talking in terms of parallelism over here, if they can see each other and still they go inside and start speaking, the situation would become ugly. On the other hand, concurrency here is something like very, very interesting. You see, concurrency, as we talked in our course, it's like your core, your CPU, it can do only one thing at a time, and you have only one processing unit. If you try to bring that in the same analogy of real world, you'll have to imagine a bit here. You see, all of us pretty much work independently, right? All of us are living parallelly. How would the world be like? Let's say there were too many people on the planet and there was only one soul. You see, like they say, husband and wife, two bodies, one soul, and if that was true, then both of them couldn't operate at the same time. You need a soul for your body to work. So what if they were sharing souls? So bringing the same idea there, it is concurrency. Assume that again Ram and Shyam are there, but then the point is, you see, it's like in a slow motion, only one of them can really move at a time, right? Or if the soul analogy is like too spiritual or philosophical, think about what if let's say they didn't have legs and they needed a pair of legs to walk, and they only had like one pair. You see, something like that. Only one of them can actually do something in the real world at a time. That is what is happening in this code. If you talk about concurrency, either producer or consumer can run at this at one time, and they keep on switching. Right, now let us discuss what could be the solution for this. We would be talking mostly in terms of concurrency here, and I will try to make it as clear as I can. So we are looking for an easy way out. Again, something that could that's easy to imagine in real world. You see, your problems always become easy if you try to imagine them in real world. That's why the entire, you see, programming languages, they shifted from procedural to object oriented, because object oriented represents real world better. So that's what we, let's say, should try to do here. And now Ram and Shyam, they both know that Ram also knows that Shyam wants to complain, Shyam also knows that Ram wants to complain, and they also don't want to go in at the same time. So they come up with this idea. They say that okay, one of us will go inside, and then you can actually lock the door. Right, you can actually latch the door, or maybe put a sign there that the professor's cabin, or the professor is busy, something like that. But a better analogy will be, let's say one of them walks and he puts a lock, right, and meanwhile there is a lock, the other one cannot simply enter. Right, it is again the same thing which we do to our secret rooms, right, which we use in our daily life. You can always go in and lock it. So we want a similar idea here. Both producers and consumers, before they try accessing the value of count, any of them, they should put a lock. And we brought that lock here with the help of a variable, let's say int lock. Right, if you already understand this concept of locks and stuff, if you already get this code and you understand why it is not working, you can simply move to the next video. If you want an understanding, please hang on. So let me say int lock equals to 0. So when I say lock is 0, 0 means it is not there. 0 simply means it is not logged. Alright, as we do with 0s and 1s, and if you see a 1 here, it means that it is logged. Right, so initially when none of them is there, there is no lock, and whenever any one of them want to go there, right, and the professor's cabin here is the critical section, right, this count plus plus and count minus minus, this part in their respective codes are called the critical section. This is critical section for producer, and this count minus minus here, it is the critical section for consumer, and we want only one of them to be executing inside this critical section at a given point in time. So this is the critical section for consumer. And now the point is, before you go on and access your critical section, you should do something here, right? You should see whether other person or the other thread is not in its critical section, only then you should be allowed to go. You have to be very careful about where you put this condition, right? Here the condition is we simply want to check if some other thread is already in its critical section, then you should wait, otherwise you are good to go. That is the logic that we want to implement here, and this logic here, whatever logic you put in here, that would be called as the entry section, right? Only if you pass this particular thing like a Lakshman Rekha, only then you can go inside and access the critical section. In our case, our idea is that of a lock, right? If there is a lock, you cannot go. If there is no lock, you can go. And we were capturing that with this idea, while lock equals to 1, continue, right? And you should really understand what is happening here. There was this very Nice question, I would say, from Kuhu, a very logical question. So she said while log equals to 1, you are saying continue, it means log equals to 1, continue. Right, but the point here is, if you look at it, it is the same code which looks like this, and you, instead of continue, you call it pass in Python, and continue means you continue in the loop, right? So if log equals to 1, continue, right? While, not if. So while log equals to 1, you keep on waiting in the same loop. You keep on looping over and over here. So if log is already applied, keep on waiting, keep on waiting, keep on waiting. That is what we are doing here. You can write it in many ways. This is the most clear way of writing it. If you want, you can also write the same thing without braces, right? Hopefully you know that if you have only one statement in a for loop or a while loop, you can do without braces. And even if you remove continue and write this line in this way, it is again the same. It simply means while log equals to 1, keep on waiting, and this is normally called busy waiting, or you might see the term spin lock for it, right? Spin lock means it's a lock, but you are again and again checking it. So if Ram wants to go into the cabin, the point is there is a lock, right, and he cannot leave, he leaves for a moment, but he again comes back. He is checking it again and again and again. That's why it's called a spin lock. So while log equals to 1, you keep on waiting. Otherwise, what do? You come out of this loop when log is 0. That means there is no lock. So if there is no lock, you come out, and then what you should do? You should put the lock before going in. You should indicate, right? The same thing. If Ram sees there is no lock, Ram goes in and locks the door. So Ram puts the lock here, or producer puts the lock here and says lock equals to 1. It is now logged. It is now logged means, meanwhile, if the consumer will try to enter here, will write a similar logic for consumer also, it will just keep on waiting, right? And then it goes on, has chat with the professor, or does a count plus plus, and once done, right, once he has done chugli with his entire herd out, he can just open the lock, right? So unlocks, he unlocks after he comes. So they are fair, they are not like really evil people, just that they have conflict between them, right? So he unlocks and he gives a chance to Sham to maybe go and have a word. And this particular reason, right, where you are unlocking it, it is also called the exit section. It is now exited. When you exit, again you should do something. So you will always see these sections: entry section to the critical section and exit section. There might be a whole lot of other code also here, right? But right now what we care is only about the count plus plus, count minus minus. There can be a whole lot of other code here which both producer and consumer should be able to run parallelly, right? Otherwise, if you say I can just simply run one at a time, right, I can execute them sequentially, a race condition will never happen. But then the point is you are not doing any parallel processing there. Think about it. So anyways, so the code for the producer is over here. Whatever code you see for producer, for consumer, it's going to be exact opposite. Consumer also does the same thing. If log equals to 1, it keeps on waiting. Otherwise, it puts the lock, executes in its critical section, and then come out and sets a log back to 0, right? So take a moment to understand this code, and if you are stuck at any particular moment, please mention it in comments. So some brownie points for comments also, so that I see, right, who is actually watching the videos and understanding this. So that's also, according to us, this logic should, you see, pretty much work. And we also saw that this logic didn't work. So if we could just go back to our terminal here, let me go back to home folder, OS codes. Yeah, let me just increase it a bit. Clear. Let's compile this file and let's try to see if the race condition is resolved. Unfortunately, that doesn't happen. I'm sorry. That doesn't happen, right? With all these changes being done to this code and with this idea of a lock, it just doesn't work. Now the question is, why is it not working? Right, again we have discussed that in the class, but let's make it more clear. And again, if you understood that, you can just skip this video and move to the next one. So you see, again in the case of parallel execution, it's like both Ram and Shyam, they arrive at the same time and both of them see that there is no lock and they together enter. Right, it's easy to see it that way, and that can be a problem. If you look at it from the perspective of concurrency, where only Ram or Shyam could actually work in the real world at a time, right? So the condition is like, let's say producer or Ram executes first, sees that there is no lock, right? Assume that the lock is 0 in the beginning, there is no lock. Ram sees that there is no lock, and you see in between these two statements here. So statement number 14, statement number 16 here, let's say my code is here, my control of the program is here. So Ram saw that there is no lock, he just entered the cabin and he's about to put the lock, but then the problem is a context switch happens here, or let's say a soul switch happens or a leg switch happens, whatever you call it, and now Ram is posed and the ball is in the Shyam's court. And Shyam comes here and says, why lock equals to 1, for Shyam also there is no lock, because Ram has not yet locked it from inside. It means meanwhile the Ram was about to lock, Shyam also comes in the same time. For both of them there is no lock, and then Shyam also sees it, and now what? Both of them are inside the cabin and both of them puts the lock. Ram also puts the lock, Shyam also puts the lock, but then the point is both of them are already inside it and both of them executes a critical section at the same time. So that is why our problem is not resolved here. The problem is between these two statements, while lock equals to 1 and lock equals to 1, a context switch can still happen, and because of that your race condition will not be resolved. So now our objective, you see, again changes. The same problem which was happening with count previously, that this count plus plus or count minus minus should happen as in a single shot, as a single atomic unit. The same problem is happening here with lock. These entire two lines, while lock equals to 1, checking the lock and setting the lock to 1, they should also happen in a single shot. So it became like a recursive problem. Right, it's again like that two cats were fighting and then you invite the monkey to solve their problem, and then there are more problems that happens in computer science all the time. You try to resolve one problem, you see another problem. To resolve the problem with count, you brought in lock, but now how do you solve the problem with lock? One way to solve those problems was again writing certain smart codes, Decker solution and Peterson solution, which were there in the lab, and it will take you some time to, you see, grasp those solutions, read them, discuss with me. But now we will be looking at a better solution. So those were the software solutions where you write a smart code to address that problem. But now we will look at another solutions which are called hardware solutions, and which are which lifts off the responsibility of programmer there, again to make the life of the programmer easy, and something which is provided by the hardware of your computer to easily resolve such issues, right? Because it's really a big problem in here. So in the next video we'll see how to resolve this, and we'll be starting exactly from this same point over here.